Alright, we're talking about the surface area of cylinders, very obviously. And I want to point out that I have a bit of a love-hate relationship with these because they are not classified as prisms, but if you remember, we'll make this as a reminder text, the surface area of a prism in our last video was the base doubled, we had two bases, and we had the perimeter of the base times the height. This was something we saw in the last video. Well, the surface area of a cylinder, while it is not technically a prism, is technically the same thing. When we go to find the surface area of a prism, we go, area of the base. So when we go to a cylinder, if it's basically the same thing, we know that the area of a circle is pi r squared. Well, that means this is 2 times the area of the base. That's the same as this. And the perimeter of a circle is called the circumference, which is 2 pi r. So 2 pi r times h. This is the formula for the surface area of a cylinder, but if you really look at it, pi r squared is the area of the base, 2 pi r is the perimeter. I don't really understand why I can't lump these together. So I do. When I memorize formulas for things, if I can shorten what I have to keep up with, this is how I go about it. I know that the surface area of a cylinder is really the surface area of a prism. It's just that they don't have a polygon mentality here. They define cylinders differently because of that circular base. The circular base makes it a classification of its own. Having said that, these are very easy to plug in and work with. If I want a cylinder to work with here, we'll do a very poor drawing of a cylinder real fast. All I've got to do is know the radius. I don't know why I dotted the top part there. I don't need to do that. I need the radius. Let's say we have a radius of 4. And I need a height. Let's call it 15. And this is going to be one of the single easiest, quickest problems you'll ever have to do, because you don't have to think about any alternative formulas for a cylinder. It has its own locked-in values here for this. So to find that surface area, it's just a matter of going and plugging values in. So 2 pi r squared plus 2 pi times r times your height. Now I will tell you, for me personally, when I do these, I prefer exact answers, which means I like to leave pi in my final answer. So for me, I would square the 4 to get a 16, times 2 would be 32 pi for the first part. And then here, I would probably start with 4 times 15, or you could do 2 times 15. Either one of those two would be fine. So 2 times 15, for example, is 30. 30 times 4 would be 120. So we'll have 120 pi here for the second part, which in sum total would be 152 pi. The reason I prefer to leave my answers this way is that this is an exact value. There's no rounding. There's nothing weird going on. And depending on what kind of program you might be working in, what kind of website you might be using for practice, I know IXL, for example, treats pi as exactly 3.14 for their problems. What can happen is, if you go in and do that, you may get a wrong answer if you're not being careful. So here, 152 pi would be approximately 477.52 if I go to the 2 decimal places, to the 100th. If I do 152 times 3.14 exactly, notice that I get a very different decimal value. So in something like IXL, you would see this as the correct answer, when in reality this is a more appropriate answer to work with here. So for me, I prefer this nice answer. In general, when I work with a calculator, if I'm going to round, I'm going to round this off using 2 decimal places and the actual value of pi. So just don't fall for that trap there if you're looking through examples or practicing things online.